afternoon, good evening, whatever the case may be. We are back in Better Than Ever, and today we are talking about complex numbers as we listen to the great U2 lead singer Bono and their classic song Sunday Bloody Sunday. We will get back to them, but let's get to it, shall we? What we are going to be doing is just working through several examples. We'll talk about proofs and specific rules in class. So, if I have two complex numbers, 3 plus 2i for z and w equals 4 minus I, and I'm asked to find these things, this is very simple. We add the real parts and the imaginary parts. So 3 plus 4 gives me the 7, and 2i minus I is equal to plus I. No big deal. So z minus w, I'll go ahead and write that out a little bit. So that's going to be z, 3 plus 2i, minus the entire w. Please remember to distribute the negative sign. So this would be 3 plus 2i minus 4 plus I, which is equal to 7. Nope, it's not equal to 7. It is equal to negative 1 plus 3i. And C, zw, 3 plus 2i multiplied by 4 minus I is going to be equal to 12. We're just going to distribute here. Minus 3i plus 8i minus 2i squared, which is equal to 12 plus 5i. And recall that I squared is equal to negative 1. So negative 2 times negative 1 is plus 2. And we end up with a complex number, 14 plus 5i. And then to simplify d, z over w, so that would be 3 plus 2i over 4 minus I. What we want to do is get the I out of the denominator. So we're going to multiply by the complex conjugate of 4 minus I, which is 4 plus I. So we would have 12 plus 3i plus 8i is 11i. Hope I'm not making mistakes. 2i times I is plus 2i squared all over. Now this is of the form a minus b times a plus b, and recall that's equal to a squared minus b squared, so we can quickly say that our denominator is 16 minus I squared, and we clean things up and we get 12 plus 11i. Recalling I squared is negative 1, so that's going to be 2 times negative 1 or minus 2 over 16 minus a negative 1 is plus 1. So we end up with 12 minus 2 is 10 plus 11i over 17. And in complex form, a plus bi, we would need to write that as 10 over 17 plus 11/17 I. A plus bi, of course, is complex number form. This is perfectly fine, but usually we're going to be wanting to be in pure complex number form. Okay. Find real numbers x and y such that these things are true. Now this is just going to be finding a way to equate coefficients. And instead of expanding this, I'm going to notice that I have x plus yi right here. So if I can move this guy over here, I should be able to equate real and imaginary parts. So I'm going to divide both sides by 2 minus I. So I have x plus yi equals negative I over 2 minus I. And I'm going to multiply by the complex conjugate. And so I'll have x plus yi is equal to negative 2i minus I squared up top. We're of the form a minus bi times a plus b, so that's going to be 4 minus I squared, which is equal to negative 2i plus 1, because minus negative 1 is plus 1, over, again, 4 minus 1, or a negative 1 is 4 plus 1, or 5. So this is going to be 1/5 minus 2/5 I. And of course, we have x plus yi equal to that if we carry that down. And equating the real part, we get x equals 1/5. And the imaginary part, we get y equals negative 2/5. That is a thing of beauty. Now here, I don't have the luxuries of having the x and the y together, so I am going to go ahead and expand this and then collect like terms in a convenient manner. So if I expand this on the left side, I get x minus xi plus 2i minus 2i squared, and that is equal to 5 plus yi. All right, so this is in complex number form, and that's what I'm going to try and do here. Clean this up a bit. So x minus xi plus 2i, and negative 2 times I squared is going to be a positive 2, is equal to 5 plus yi. What I'm going to try and gather are my real parts and my imaginary parts. So my real part on the left side is the x and the 2. So I have x plus 2. And if I factor out an I plus, I get 2 minus x. It's negative x plus 2, but I'm just rewriting it conveniently. And that's equal to 5 plus yi. And you can see I have the real part and the imaginary part. So I can set them equal to one another and get x plus 2 equals 5. And of course, x equals 3. And then I can equate the imaginary parts. 2 minus x would have to be equal to y. I've already solved for x. It's 3. So 2 minus 3 equals y, which means that y is equal to negative 1. Equating coefficients is a very nice method of solving equations at times. All right, so moving on. Complex conjugates, or complex numbers. We've already done this. A plus bi and a minus bi are called complex conjugates. So if we have z in the form a plus bi, we can write its conjugate as z star, which is what we'll call this. Z star is equal to a minus bi. So we don't have to keep writing this out. We've already done work with it. We'll talk more about this in class here. We get a theorem if c plus di and c minus d are roots of a quadratic equation. Then the quadratic equation is a times x squared minus 2cx plus cd squared plus d squared equals 0 for some constant a not equal to 0. There's a proof here, which we will talk about in class. And the sum of the complex conjugates c plus di and c minus di is 2c, which is real, as well as the product, which is also real. So this is a quick way that if you memorize this, you can always answer questions like this right here. And let me just go back because I did miss something that I meant to. If we have a quadratic equation and it has a root c plus di, then the complex conjugate c minus di is also a root. And of course, depending on the sign of d, it might be in the form of c minus 2i, or like, for example, if you had, I don't know, if you know that 2 plus 3i is a root of a quadratic, then you know 2 minus 3i is also a root, or 7 minus 5i is a root of a quadratic. You know that 7 plus 5i is as well. Okay, so let's do an example. find all real quadratic equations having 1 minus 2i as a root. All right, well, if we know that 1 minus 2i is a root, then we also know that 1 plus 2i is a root. So if we use this handy-dandy formula, then we can quickly do this, okay? So the sum, let's do the sum of the roots. So 1 minus 2i plus 1 plus 2i. The 2i's go away. That's a terrible 2i, and we get 2, okay? And if we do the product of them, let me extend the page. 1 minus 2i times 1 plus 2i is equal to a squared minus b squared. So that's 1 minus 4i squared. I squared is -1, so that is equal to 5. Okay, so what do we have here? What's happening? Well, we are of the form using this right here. We know that the quadratic is of the form a times x squared minus 2cx plus c squared plus d squared equal to 0. Okay, so let's explain a couple of things. The sum of the roots is 2c, so that's 1 plus 1 is 2, okay, which we already did. And then is equal to c plus di times c minus di, which is what we did here. So this means this becomes a times x squared minus 2x plus 5. So what this represents, well, I should say this is equal to 0, and I shouldn't have an equal sign here. What this represents is all real quadratic equations that have 1 minus 2i as a root. And it's a real quadratic because all of the coefficients we're using all real numbers here. And we know we have all of them because we're multiplying by the constant a. And so any multiple of this is still going to have the root 1 minus 2i because we could always factor out the a, divide by a, and it comes down to this basic quadratic. Now, do you have to memorize this? No, not necessarily. If a and b are roots of a quadratic, then we know that the factors are x minus a times x minus b. Well, the same thing is true here. If I have 1 minus 2i and 1 plus 2i as roots, then I know that x minus each of those roots is going to be factors of that quadratic. Now you have to be careful. You have to distribute the negative here. I'm subtracting all of this, so subtracting 1 minus 2i, I have x minus 1 plus 2i multiplied by x minus, then if I subtract this one, it's x minus 1 minus 2i. Okay? And I'm going to go ahead and put the a in front of there and just forget about it until I do all this simplifying. So, how does that work? Well, this is going to be a times all of this mess. Okay? X times x, x squared. X times -1, negative x. X times -2i, negative 2xi. Then I'm just going to line up factors. X is a negative x. -1 times a -1 is a positive 1. And -1 times a -2i is a plus 2i. And we'll see if we can get any friends for these guys. 2i times x is plus 2xi. So that lines up right here. 2xi. I'll put a plus in front of there. 2i times -1 is a negative 2i. And then positive 2i times negative 2i is a negative 4i squared. What? Parentheses. Okay, so what happens here is I end up with a x squared has no friends minus 2x. Okay, this minus x and minus x is minus 2x. These two cancel. The 2i and negative 2i cancel. And then I have 1, and negative 4i squared is negative 4 times negative 1, or plus 4. 4 plus 1 is 5. So you get the same thing just by expansion, just like you've done all along. So you have the choice. You can either memorize this. I like to just to do the algebra. It seems, I mean, I guess this is quicker if you memorize it, but we got a lot of things going on, so I leave it up to you. I just wanted to show that to you. So that puts us at a good stopping point, and we'll continue with part 2. And with that, I am out.